Hello everyone, let's get started again. Okay, in this video, we extend our last discussion, right? We are going to discuss those findings further. The last video, we discussed very important relationship. First, we derive the identity between permutation symbols and Kronecker delta, right? So this is the relationship, right? The first one. That means when you multiply two permutation symbol, the subscription indices completely different. This is the equation. Then we discuss when the last uh, subscript of the previous permutation symbol equal to the second uh, permutation symbol first subscription, then we reduce this determinant to this form, right? Okay, then finally when last two and first two is repeated same, then we derive these equations. Okay, so now today what we are going to do, we are going to discuss if all three indices of permutation symbols are equal. If these three and again multiply by same itself, right? So in this case, because I'm going to use our previous findings, I'm going to write this one because I, J, K, we already discussed. When it is follow the same order, it doesn't change the value. So that means IJK, I can write KJ, yeah, KIJ, right? Or JKI, right? I can write something, right? So that means epsilon IJK equal KIJ, right? Epsilon KIJ, right? Or JKI, anything I can write, right? So now from here, I will write this way, right? JKI instead of this one, I will write JKI, right? JKI, right? Okay. Now you can see the last two digit and first two digit same. So that means our previous one, right? JK, JK, right? So here also JK, JK. So now what I can do if I want to use the previous finding. So what we did there, the common indices we remove, then we combine another two indices. In this case, the first and last one. Okay. So that means here these two is common. Then we combine the first and last, right? So that means these two, right? Okay. The same thing I'm going to do here. If I combine the first and last, if I apply the previous one, 2 into delta I. But we know already we discussed delta II equal 3, right? So that means now we will get 6. Okay. Again, this is very, very another important relationship you must remember. Right? Okay. Right. So now what I'm going to do, I'm going to use these findings and develop an indicial notation for determinant of a matrix. For this, I'm going to use our triple scalar product findings. You remember we discussed the triple scalar product index notation, right? That means AI, BJ, CK, epsilon IJK. This is our triple scalar product. You remember, I think. So it will be the lecture notes, right? Yeah, here you see this relationship. The same thing I'm going to write there, right? Okay. So now if I write that one here, so this is equal actually the determinant of this one, right? A1, A2, A3, then B1, B2, B3, C1, C2, C3. Okay, right. Now using this relationship, what I'm going to do now, I'm going to write the determinant of A, matrix A. Okay. So determinant of matrix, I can write Aij, no problem. We will write it this way. So now the determinant of this one, that means A11, A12, A13. So there is a difference between the previous determinant and this one. Previous one, the coefficient is vector, right? Vector coefficient. Not coefficient is not a vector, it's a coefficient of vector. A1, A2. Here we have A11. Here we have two subscript, right? So we have to be very careful. So I'm going to use the previous finding to extend the index notation of this one, right? Similarly for this case, A21, A22, A23. This one A31, A32, A33. Okay. Let's see. I'm going to use this one here, right? So that means to represent this one, the same thing I'm going to use. The previous one I'm going to use. The first one, you can see the first subscript A1, A1, A1. Only the second subscript is changing, right? Therefore, if I consider the second subscript for the consider only the second subscript, then I can apply the previous one. Previous one, what is he saying? Change similarly for the second case also. Second subscript is changing. First subscript is fixed. Third one also same, right? So therefore, I'm going to use for the second subscript our previous findings, right? So what from based on our previous findings, I will take the second subscript as M, the first one. Instead of AI, I'll write AM. Second one B, but here we have again A, right? So I have A. So now instead of the second subscript, I use J. Here instead of that one, I will use N, right? Okay. Similarly, for the third subscript, I will use L, right? Okay. So these three I have written to the first three. Then I have to write epsilon ijk. For that, what is that? M, N, L equal. That is actually what is that? Determinant of A, right? So determinant of this one, determinant of A. Okay. If I write determinant of A, right? Okay. That's all? No. We have to do one more thing, right? I don't have place. Therefore, I will move a bit this side. Okay. You remember we studied in our very first or no our second continuum mechanics video. In our second continuum mechanics video, we discussed the rules for index notation, right? In the rules, so one of the rules I told you, when you apply this one in the equations, this equation must satisfy the number of free index left hand side as well as the right hand side. If you see the left hand side, so left hand side, it's fine. Now you don't have any free index now because M is the repeated index, N is the repeated index, L is the repeated index. No free index here. Now what I'm going to do, because in this matrix, we have two subscript. So I introduce only the second subscript here. The first subscript I have to introduce here, right? So I will use I, J, K. What is this ijk? Now I am applying the first subscript. But you can see this ijk now, it is a number of free. It is a free index. Ijk are free index. So we have three free index this side. So therefore, the same number of free index, you have to introduce the right side of equation. Then you have to be very careful. when you introduce any subscript, that means pre-index in right side of the equation, you shouldn't change the equation determinant of A, the value of determinant of A. So without changing one value, if we want to introduce some factor here, we will introduce number 1, right? Unity. You can introduce +1 or -1. Why +1 -1? Because this side we have permutation symbol. We don't know whether it is +1 or -1. If it is -1, you can apply -1 here. +1, you can apply +1 here. So that means, again, we can apply one permutation symbol here. It must has the free index ijk. Why same ijk? Because this side we have ijk. This is very important relationship, right? Okay. Now from this, I'm going to find the value for determinant of A. To find determinant of A, what I'm going to do, in this previous equation, I'm going to multiply both sides epsilon ijk. So that means this side I am going to multiply. Already we have one epsilon ijk. So now I am multiplying epsilon ijk this side, right? Okay. Equal. The same thing will be there, right? AIM, AJN, AKL, MNL, right? In addition to this, because I multiply both sides ijk, the same ijk will be this side. Okay. Now, the left side one, this is already we discussed, that is equal to 6, right? So therefore, determinant of A now, so this will be 6. This is already we discussed, right? This is equal to 6, right? So now if I take this 6 other side of the equations, determinant of A will be 1 by 6. I will write permutation simple front, right? ijk, M and L, because I can change the order because this is just a scalar, right? No problem, right? This will be AIM, AJN, AKL. So this is the equation for determinant of the matrix, right? Very important equation. Okay. Right. Again, determinant of A, it's a scalar, right? Because this is a scalar, all the indexes are repeated index. Therefore, this is a scalar. It is not a vector or a tensor, right? Okay, right. So this is another important thing, right? You must notice. Okay. Uh, right. So one more thing, it was popping up on my mind. Then I think it's now blank, right? I have forgotten. Okay, let's see. When I discuss something, then later definitely we will discuss most of the things, right? Okay. Uh, right. So this is the way we define any determinant of A of the matrix, right? Okay. Right. So let me stop at this point, this video. This video, I think it's not that much lengthy. Then I will move some practice questions in the next video. So after that, I'm planning to start uh, transformation of coordinates, right? So before that, I think yeah, if I discuss some important other stuffs in regarding the uh, eigenvalue, eigenvectors, those things also, right? So let's see. Let's plan. Okay, let me plan the next video contents. Then we will discuss, right? Okay. So if you have, again, as usual, if you have any questions, let me know in the comment section. If you need some any additional proof, let me know. Then I will upload the separate videos, right? Sometimes some people they might have forgotten something, right, from these things. But okay, I mean, if you are an engineering student, definitely you might have completed the engineering mathematics, right? So therefore, you can refer those things in your mathematics, previous mathematics stuff. Um, so anyhow, if you need any clarification in those mathematical content, so let me know. I can upload in a separate video rather than disturbing this playlist, right? Okay, so I'll meet you in another video. Then please share this content with among your friends and then support to my channel. Okay, so definitely this will help. This will be helpful for any students, those who are pursuing their degrees in masters or PhD, even undergraduate students who are in final year, right? Okay.